Hello friends, welcome to my channel Dr. Online 24/7. Today I'm going to tell you about antimicrobials resistance, AMR. One of the top global public health issues facing humanity. So, what is it? Why is it a problem? What are the main drivers? And, how do we to prevent it? Let's start by taking a look at what antimicrobials are. Antimicrobials are agents that kill microorganisms or inhibit their growth. While they have been used in various forms such as herbal treatments for thousands of years, the modern era of antimicrobials began in the early 1900s with the creation of a compound called salvarsan and the discovery of penicillin. Since then, many different types of antimicrobials were developed, revolutionizing medical practice. They are a key tool in our fight against infectious diseases. How do they work? Antimicrobials typically work by entering an organism, binding to specific target sites, and blocking important processes in the organism that either kill them or stop them from multiplying. But, organisms have developed several ways to resist antimicrobials. This is called antimicrobial resistance or AMR. There are several mechanisms by which they become resistant. They include preventing access of the antimicrobial into the organism, removing the antimicrobial using pumps in the cell wall, destroying or inactivating the antimicrobial with enzymes, changing the antimicrobial target so that it cannot latch onto it, or developing new processes that avoid using the target of the antimicrobial. These resistance traits can be passed on from one generation to the next and also spread between organisms through various genetic elements. Cross-resistance can also occur, where an organism that is resistant to one antibiotic can show some resistance to other types as well. Consequences: AMR can occur in bacteria such as Staphylococcus aureus and Mycobacterium tuberculosis, viruses such as influenza and HIV, parasites such as Plasmodium falciparum that causes malaria, and Leishmania species that cause leishmaniasis, and fungi such as Candida auris and Aspergillus. Note that antibiotic resistance is a type of antimicrobial resistance that is used to describe resistance to antibiotics that are used to treat bacteria. Resistant organisms are sometimes called superbugs. Of particular concern are organisms that are multi-resistant, showing resistance to more than one antimicrobial, or those that are pan-resistant, showing resistance to all known types of antimicrobials. The consequence of AMR is that antimicrobials become ineffective, and therefore, infections are harder to treat. Diseases that were once treatable may require treatment with alternative drugs which may be more expensive, require treatment for longer periods of time, or not have any effective treatment at all. Procedures such as surgery, chemotherapy, or transplantation can be very risky without the protection offered by antimicrobials. AMR can lead to adverse clinical outcomes including death. In addition to this, AMR can also have a significant economic cost. At an individual level, it can reduce productivity and increase healthcare costs. At a health systems level, there can be high costs associated with treating patients with severe or prolonged illness. Drivers. Let's have a look at the drivers behind the increase in AMR. AMR, a natural evolutionary process that microorganisms use to avoid destruction and survive. However, there are several drivers that have accelerated this process. The main driver for AMR is the unrestrained use of antimicrobials in humans and animals. Antimicrobials are one of the most commonly prescribed drugs for people. but unnecessary and inappropriate use is common. For example, using antibiotics for viral infections or not completing the full course of the medication. Antimicrobials are widely used in animal husbandry not only to treat disease but prophylactically, to prevent infections and as a growth promoter. Other drivers of AMR include poor water quality, sanitation and hygiene, inadequate infection control practices and inappropriate food handling. These provide conditions in which resistant organisms can emerge, multiply and spread. To add to this issue is the fact that there are few new classes of antimicrobials being developed. Preventing AMR. So how do we prevent AMR? AMR is a complex problem and preventing it requires a multisectoral approach. The World Health Organization's Global Action Plan provides a good framework to tackle AMR. It outlines 5 strategic objectives. These are: improving awareness and understanding of antimicrobial resistance through effective communication, education and training. Strengthening the knowledge and evidence base through surveillance and research. This includes research to develop new treatments, diagnostic tools and vaccines. Clinical studies on effective antimicrobials or alternatives to antimicrobials. Reducing the incidence of infection through effective sanitation, hygiene, and infection prevention measures. This is particularly important in healthcare facilities. It also involves promoting hand hygiene, food, and water safety, developing new vaccines, or promoting the use of existing vaccines. Conclusion: optimizing the use of antimicrobial agents in humans and animal health. These include: at an industry level, stopping the inappropriate use of antimicrobials in agriculture. Having antimicrobial stewardship programs, which are organizational or system-wide healthcare strategies to promote the appropriate use of antimicrobials through the implementation of evidence-based interventions. And at a national level, having a strong legal and regulatory framework to ensure the rational use of antimicrobials in animals and humans. Ensuring sustainable investment, and increasing investment in new medicines, vaccines and diagnostic tools. These actions require a whole-of-society approach with everybody, in all sectors and disciplines working together. It includes taking a One Health approach incorporating human health, animal health, and environmental factors into consideration. And that's an overview of AMR. That's it for today. Hope you like it. Thanks for watching Dr. Online 24/7 by Dr. Sana Bawani. Don't forget to like, share, and subscribe my channel.